Welcome to an introduction to clinical histology. In this lesson, we're going to talk in a little bit more detail about the use of paraffin, as it plays a major part in many of the work areas of the clinical histology lab. But first, let's think of a few variables to consider when we work with paraffin. One variable is the melting point, and density is the other variable that I can think of. And those kind of work hand in hand. So if a paraffin has a low melting point of 52 degrees Celsius, it tends to be a softer paraffin. And if it's 60 degrees Celsius, it tends to be a hard paraffin. So there are many melting points in between those two. Those are the two extremes. And today we'll just talk about the two extremes. So why would you want to use one or the other, I guess would be the question. And I would answer that by saying that there are pros and cons to each of them, and everything in between, of course. But with a hard paraffin, let's say the one that's about 60 degrees Celsius, works well with sections of tissue that need to be cut very thin, or tissue types that are hard, like bone that has been decalcified. And with paraffin that's very low in melting point are useful in that there are tissue types that don't survive well in paraffin that's at a melting point of 60. The downside to that is softer paraffins need to be cut thicker. So I wanted to show you a couple of brands of paraffin to give you an idea of what the bags look like and where to find the melting points on them. Here's a McCormick brand, and they have a melting point which is located here at 52 degrees Celsius. Let me see right there. Here's a Leica brand, and they have a range of 56 to 58 degrees Celsius, and you can find it right there. So now that we know a little bit more about some of the variables, let's talk about the uses of paraffin in the different work areas. So starting with accessioning, paraffin isn't used in accessioning or grossing, which is the next work area. But in the tissue processing area, paraffin is used. And the major function of paraffin is to replace the water that has been removed during the tissue processing. So this is a representation of what steps occur in the tissue processor. And this sponge is a representation of tissue. So this is tissue. So in its natural state, tissue is full of water. And in the tissue processor, the first major step that happens overall is water is removed. And then it goes into a non-aqueous solution. In this case, it's going to be alcohol. So alcohol, 100% alcohol, is non-aqueous. And once it goes through the non-aqueous solution, it goes into a solvent, which removes the alcohol. But now we need to remove the solvent and ultimately replace it with paraffin. That's the final step. So basically, once it goes out of this non-aqueous state or solution, it goes into the hot paraffin. And that's its final step. So this would be the last step, is that the tissue is filled with hot melted paraffin. And you notice that the sponge has kept its original state, and that's the main idea, is to preserve the morphology of the tissue as best as possible, and these steps allow that to happen. So, and once that's done, keep in mind it's hot melted paraffin that's perfused in the tissue at this point. it gets carried over to embedding. And again, paraffin is used in this area as well. But at the beginning, it's hot melted paraffin, and at the end, it's solidified. I think now's a good time to talk a little bit about the overall goal of embedding, and that is to take the tissue and orient it and place it in the correct plane, and when that's done, freeze it in that spot permanently so that it doesn't roll, turn, or move during the cutting process. The next work area is cutting. We cut on microtomes, which is what this is. And the reason we like to use paraffin is because it's a great medium for cutting. When tissue is solidified in paraffin, it doesn't move. And we like that because it's in the correct orientation and plane, so that when we slice it with a razor, with a histoplate, it's exactly the way we want it, and we can do it over and over and over again, and it doesn't move. So it's a great paraffin is a great medium for cutting, and that's why we use it. So after we cut tissue, I guess I can demonstrate that for you here. So you notice that nothing is moving. This is a block holder, and this is a mold that has been embedded. A piece of tissue is inside there, and this piece of wax is holding it all inside there. And this is the razor blade that's cutting this block right here. So as I cut, you can see the sections, or the ribbon being made. So after we cut a piece of tissue and we place it on the water bath, in regards to paraffin, what we really need to think about is that we need to soften the paraffin so that it's flat. And that works well with with water, warm water. Now, if we're working with a paraffin that's 52 degrees Celsius as its melting point, we want to go about 10 or 15 degrees lighter than, or cooler than that, because we don't want to melt the paraffin. We don't want a 50 degrees Celsius water in here, because if we did, the paraffin would melt and everything would just disassociate. So we want the tissue to stay in place. We want the paraffin to stay in place, because it's holding the tissue in place. But we want it all to soften up and remove any kind of wrinkles or any deformities or anything like that. And warm water does that well. So once the wrinkles are gone, we can pick up the ribbon of tissue, or one section of the tissue. We'll just demonstrate that for you here. There's one section. And now we have one section of tissue on this piece of wax. So now that we're done cutting, the next work area is staining. So we can't just send this to the staining and just put some stain on this, because the great thing about paraffin is it protects the tissue. And so it would do that. If you put it in a stain, it would just not stain it correctly or at all. So we need to remove the paraffin at this point. And the way we do that is, well, we first heat up the paraffin on the slide in an oven, which doesn't remove paraffin. It does remove some of the excess, but what truly removes paraffin is a solvent, and a popular solvent is xylene. So once you do that, once you remove the paraffin with xylene, it does keep the tissue there, by the way. You would look up in the light and you can see a little speck of, in this case, a little speck of tissue on the slide as the tissue remains on the slide, but the wax is removed. And that would be the final step in the histology department. Once it's stained, it goes to the pathologist for review.